Hello guys, today we are going to talk about ultrasonic sensors and interfacing it with our STM32F4 board. Ultrasonic sensor is used to measure distances by transmitting a wave and receiving it, and by reading the time at which I receive the wave from ultrasonic sensor. I can know the distance through a relation with time and speed. You can get distance through the speed value. And we have a fixed speed value, which is the air speed 340. Let's know the operating voltage is 5 volt. Maximum range you want to read is 5 meters, and minimum range is only 2 centimeters. With a measuring angle 15 degree, which means that anything in a 15 degree you can, and it blocks the wave will read it successfully. And you have a 10 microseconds trigger. Let's see it here. Here you are sending first the wave you are sending is through the trigger pin, and it is a 10 microseconds wave, still up for a 10 microseconds, and then it will return a wave here, and you need to read the time at which this wave lasting up. By knowing the time and through that formula, you can get your value easily. So let's suppose that I got here the wave lasted for 20 microseconds. So by dividing 20 over 58, you will get a centimeters value, or by 148 you will get an inch value. So I don't know if there anything you want to know here, but I think it's too easy to use it. So let's go on through the code I made here. First thing, I initialized my timer and my GPIO pin. Let's go on. Enabled my timer clock. I'm using timer 1 and choose the up counting direction. And here you want to have an increment in your counter by 1 every 10 microseconds. So let's indicate it here. Here is the value you are getting every second in the counter if you are not using any prescaling value. And here is the value you are getting every 10 microseconds if you're also not using any prescaling value. So by prescaling it here, by dividing it over 1680, you will get a 1 increment in your counter every 10 microseconds. So you only have to put that in your prescale value, and you know that you are getting it. So here I'm getting an increment in my counter every 10 microseconds. And the auto reload, I'm not using it here, so I indicated it as FFFFF, which means a maximum auto reload value. You don't need to generate any update events through the counter. And initializing my GPIO, I used pin A9 to output my pulse, which is going to the ultrasonic sensor. So here you are enabling the clock of GPIOA and choosing it as the output, a very high speed, and no pull up, no pull down. I'm not using any pull up or pull down methods. And here I started my counter, and here I enabled my output pin to send my pulse. Here I enabled it, and I'm checking if the counter value is 1. That means that I got my first 10 microseconds, and I need to disable the output pin right now. So once it is a 1, so my 10 microseconds pulse is successfully generated, and I will break here. And here I have 2 while loops, and those while loops I am checking my receiving pulse. First, as you can see here, it has first a rising edge, then a falling edge. So here I'm waiting till I got the first rising edge. If I got it, I will go out, and then I'm waiting till it returns to be 0 again. Here I'm reading the counter value. After I got from here, I'm reading the counter value. As you can see here, by dividing the counter value over 540, you will get your meters value, and by delaying 1 second, you want to read every 1 second a new measurement, and here you are generating an update event to reinitialize your counter again. So once again, it is not really the best method to use it. You can use also a line interrupt, and you can detect the falling edge. It is better than that, but I was in a hurry. I didn't use interrupt here. It works fine with me, but interrupt will get you a more accurate value than this here. Only I'm using it to read the timing here, and then by dividing the time, you can read your measurement. Let's just flash our program. Okay, open file, my project.x. Let's flash it. Okay, cool. Let's disconnect from here. Here I'm using STM Studio, which using trace unit in my discovery board to read the values. So you can do it. Let's just test our ultrasonic. As you can see here, changes. Okay, let's go far away from it. Oh, it works fine. Maybe sometimes you will get some garbage values, like the one with 34. Okay, as you can see, oh, like that. As you can see here, it works fine. And here is the wiring: 5 ground, 5 volt. It is BA8, BA9. Oh, here I didn't in my GPIO initialization, I didn't initialize BA8. As you can see here, all is 9999. That's because the reset values of BA8 registers are input, so I don't need to choose a mode here, as the reset value of the mode is an input mode. It is not recommended to do it, but as I told you, I wanted to do it as fast as I can. It is not recommended, so build up your code and ask me as you want. Thank you.